I know, math is exciting, isn't it? Today we're going to start chapter 10. So I gave you a little bit of a taste, at least verbally, of what chapter 10 was going to be about last week. Chapter 10 is counting methods. And so if you've ever watched like the Poker Channel when it tells you like the percentage chance of one person winning versus the other, or if you've ever talked about the odds or the likelihood of something happening, this information in this chapter is sort of the precursor to doing those kinds of questions, okay? So this is what comes before that. Now what we're going to do today is we're going to look at ways of systematically counting something, and we're going to do it by making lists. And the amount of problems and the types of problems that we look at today are going to be small lists, and we're going to talk next class period when we get to 10-2 about what happens when the lists would be maybe too unruly to actually make, and so we're going to have different methods for counting then, okay? What we're going to do today is counting by systematic listing, and we're going to give you an example. So we're going to start with a group of students. The students are Abigail, Bailey, Nate, David, Elias, and Macy, and we're going to list the different ways of forming the kinds of groups. Now, I recognize that not everyone in here may know these particular names, and you may not know which names are boys or girls. So we're just going to do this all together first to make sure everybody's on the same page. Abigail would typically be a name for a girl. Okay, that's my daughter's name. So this one's a girl. All right, let's use pink. How about Bailey? That's usually girl too. Nate? I put boy. I meant girl. Let's try that again. Nate's a boy. David? Boy. Elias? That's my son. That's his name. So it's a boy. Sometimes people think that's not spelled or sounded as Elias, and then they think it's a girl, but it's a boy. And Macy? Girl. Okay? So we're going to need that information as we go through this particular problem. Here's something else to notice. These particular names, and your book does the same kind of thing every time it gives you a list of names. It gives you names that are all different first letters. Do you guys see that? Like there's no, it's not Abigail and Aaron. We don't have two A's listed here. So the reason that they're doing that is so that when we make our creative lists down here, you don't actually have to write out Abigail. You can write the letter A, and you don't have to do as much writing. Okay, is everybody with me on that? So it's kind of it's enabling us to use a little bit of shorthand in our list making. Okay, all right, so let's take a look at the first question. We're going to create a group, and this group has a president and a treasurer, and the condition is that they're not the same sex. Okay, we've got one boy and one girl. Does that make sense for everybody so far? So as we create our list, we don't want to do it haphazardly, because if we do, we're going to miss somebody or we're going to list something twice. One of the two things is going to happen. You're going to either get too many or not enough, and you may get the right number and still not have the right sets of people. All right, so the first thing I'm going to do is I'm going to start out with the first person, which is Abigail, and it's an A. And we said Abigail's a girl. So if Abigail is the president, listed first, who could be the treasurer? Nate. So we could have A-N. Or who else could be the treasurer? David. So we could have A-D. Or we could have who? Elias. So these are the three ways that Abigail can be president, but I can also reverse every single one of these because she could have also been the treasurer. And that would be a completely different listing. Does that make sense? Her role would be different, and the boys that she's paired up with, their roles would be different. So these are my first three. My second three would be the same ones, but switched. And then I contend that Abigail has no more listing that she gets to be in. Right? We've listed every way she can be president and every way she can be treasurer. Now we go to the next girl. Who would we want to use? Bailey. So we could have Bailey as president, and who could she be with? Nate or David or Elias. Yes. And we can do the same thing to this list that I did to the first one, right? I can switch them all. So I can turn Bailey from being president into being treasurer, but with the same person that she would be working with. So I can do DB and EB. And that's all the combinations, all the different ways I can write down Bailey in one of these roles. So far, so good? Okay. Last girl's Macy, right? So we're going to list Macy. And I can pair her up with each one of the boys, just like I did with Abigail and Bailey. So I can do MN, MD, or ME. And then what do? I switch them. So I've got NM D-M-E-M. And by doing it in this way, I don't need to put the boys in order and do the same thing, right? Because I already put them in there. So for instance, if you wanted to find all of the places where you had, let's say, let me change my color. Let's say we want to find all of the ones that had an E in them for Elias. Well, here's an E, and here's an E, and here's an E, and look where they all are. They're all along the bottom. And how many different groups is he in? 6, just like each one of the girls were, right? And we could do the same thing through the middle with David or through the top with Nate. Okay, so it doesn't ask this on this problem, but I'm going to ask you this question, and I want you to jot it down because we're going to come back to this next time. How many different groups did I get? 18, right? So there were 18 ways that this could happen. Just jot it down, not because your book's going to ask you in this section, but it is going to ask you when we get to 10.2, and I want to show you that this organized list way would give you the same thing that the rules are going to give us of how to do this in section 2. So there's 18 on this one. Okay, ready for the next one? Okay. The next one says that we've got the same group of kids. I've got a president, a treasurer, a president, a secretary, and a treasurer, and they tell us the condition is that the president and the treasurer are women. Okay? So before you get too carried away and maybe overlook or assume something that you weren't told, what does it tell you about the secretary? Nothing. So what does it mean about the secretary? It could be a boy or a girl. So don't assume that just because it said that the first one and the last one were women, that means that the middle one was a man, because it doesn't say that. Okay, so be real clear about what it does and doesn't tell you. So as I'm listing all these, the other thing that makes this different than the last one is what? There's 3 things I'm listing. So when I write these groups, I'm going to be writing 3 letters together instead of just 2. Okay? So let's start at the beginning. We've got a president, and we know that that president has to be a woman, a girl. So I'm going to start with Abigail, A. Okay? Because she's listed first. That's the only reason. And then I'm going to just go in the order. The next girl listed is Bailey, correct? So I'm going to list her last because they write the president and the treasurer sort of on the outsides of this. Does that make sense? I'm going to put the secretary in the middle just because they're listed that way in order. So who could be secretary? Nate could. Is he next? Yeah, he's there. Who else could be secretary? David. Who else could be secretary? Elias. Who else could be secretary? Macy. And this is all the ways that Abigail could be president with Bailey as her treasurer. Agreed? But couldn't I also switch this again, like I did on the last one? Switch column 1 where the A is and column 3 here over here where the B is, and I would have a different arrangement with Abigail as the treasurer and Bailey as the president. So I'm going to do that on this. I'm going to write down B and A, BDA, and BEA. Oh, one more, BMA. Now what this did, and this isn't the only way to organize these lists, but what this organized list did is it showed you all the ways to pair up Abby and Bailey in those 2 outside roles, right? Okay, so I don't need to pair up Abby and Bailey in role 1 and role 3 again. I'm done with them. But I do still have other options for Abigail. What else could I do? I could put her with Macy. So I could put Abigail first and Macy third, right? So I've got A and M listed first and third. And who could go in the middle? Bailey could, or Nate, or David, or Elias. And now that I have this list, what can I do? Flip it just like I did before, right? So I can take and rewrite this as MBA. I get some interesting acronyms as I do these things sometimes. So if there's any that are inappropriate, just pretend like you didn't see them. MNA, MDA, MEA. And then I think I'm done with Abigail, right? I've listed every way that she can be president with every combination as her treasurer, Bailey or Macy. And then I've listed every way she can be treasurer with every combination of Bailey or Macy as president. What's the only thing I haven't done? Macy and Bailey together. So I'm going to put Macy first. Well, I'm going to put Bailey first, sorry, just because she comes first. So Bailey's first, Macy's third. Who could be secretary? Abby could. Yeah. Or Nate, or David, or Elias. And then what can I do? Switch my list. So I'm going to do the same list, but I'm going to list them backwards. M-A-B, M-N-B, M-D-B, or M-E-B. I think I'm done. How many did I get this time? 24. 24. Again, it doesn't ask you that on this particular problem, but we're going to come back to this next class period, so I want you to jot the 24 down. Any questions on this one? Okay. Problem 3 says a committee of 2 people. What's different?
There's no gender.
There's no gender. There's no gender descriptions, right? That's different than the last ones. What else?
There's only 2.
There's only 2, kind of like the first one I did. And what else? There's no positions listed, and that's really important. Do you guys notice that? You see, when there's no positions listed, what that means is that I don't have to do any of these switches. Because if I put Abby and Bailey both on the committee, and they don't have a title of what their job role is, it doesn't matter if I put Abby on the committee first or Bailey on the committee first. Does that make sense? So I'm not going to do any of these switching around things that I did before. Okay? That's something different when you're dealing with the committee. All right, so let's take a look at this one and get going. We are going to start out with Abby because she's first. All right, so we've got A. Who could she be grouped with? Bailey, or with Nate, or with, or Macy. And I have no other piece that I will write down that will have an A in it. I will not write down an A again because I've grouped her with every single option, so I will not be listing her again. I'm done with her. Okay? So then if I move on, I start with Bailey. I don't need to list Bailey Abby because I've already done that. I will start out by listing Bailey Nate, and then Bailey David, Bailey Elias, and then Bailey Macy. And you notice there's one fewer than there was in the list before because what's missing? The Abby one, because I had already listed it. Okay? So I am done with Bailey. Next person is Nate. So we'll start with Nate. Who could Nate be grouped with that I haven't already grouped him with? David, or Macy. And I'm done with Nate. One fewer than the last column, right? Okay, I've got David left. Who could David be grouped with that he hasn't already been? Elias or Macy. And then I've got one left, don't I? Elias and Macy. How many did I get? 15 ways, or 15 committees. And again, it doesn't ask that question, but we will have that question asked later. Okay, any questions on this? Okay, so you're going to have some of this where you're listing different things. The other thing you're going to have is questions that look like this one right here. So this one doesn't even have a question yet. It's going to have us create something. So I want to talk about how to create what it's asking me to create. So this says we're going to roll 2 6-sided die. And you got the dice right, you know. They're equally weighted, so it's not like one number's more likely to come up than another or anything like that. They're all going to come up equally likely. This one says create a table of summations of the 2 dice. And then it says determine the number of ways to get the following sums. So I'm going to show you the kinds of ways that you can create a table. And I'm going to show you how your book does this table in 2 ways as well. So let me first show you the table that is the simplest way to draw it that your book will show you. All right, so when you have a die, so when you have a die, just a single die, what are the different numbers that can come up on a standard die? 1 through 6. I'm going to write those numbers 1 through 6 along the top. and then along the side. And what I'm going to create is a summation table at the moment. So I'm going to put a plus sign here just to remind us of what we're doing, okay? So what I'm going to do is no matter which row I'm on, rows like this, and column I'm on, I'm going to add up the row number with the column number to get the sum of the die. So we're going to fill in across the top first. So if I have the 1 and the 1 and I add them together, I get a 2. And if I have the 1 and the 2, I get a 1 and 3 gives me 1 and 4, 1 and 5, 1 and 6, 7. And that fills in the top row of my table. It's actually the exact same thing that I'll get for the first column of the table, right? Because this first column actually does the same thing. It takes this number 1 with this 1 to give me 2, this 1 with this 2 to give me 3, and we're going to go down. And then I've got 1 and 3 is 4, 1 and 4 is 5, 1 and 5 is 6, and 1 and 6 is 7. Okay? Now, if you take a look at this one, we've got this 2 and this 2, which gives me a 4. And then I've got 2 and 3, which is 5. And then 6, 7, and 8. They're increasing by 1 every time, right? We can all see that. And the same thing for my column. I've got then 5, 6, 7, and 8. And I can keep filling in the pieces of this, doing this addition, and they will all increasingly fill in the same way. So then I've got 6, 7, 8, and 9. Then I've got 7, 8, 9 below. I've got 8, 9, and 10 across, and then 9 and 10 below. 11, 12 across, and 12 below. And then, okay, I screwed something up. Oh, I skipped my 10, didn't I? Thanks, Mackenzie. There's a 10. Here's my 11. Here's my 11 then, and then I've got my 12. Good. This is a summation table. I'm going to use this summation table, and I'm going to come back to the screen, and we're going to draw the table one other way. Okay? So let's use this table to answer a few questions. Notice a few things about this table, though. This table has beautiful symmetry. Right? It was easy to create because all we did was add the number 1 to every successive digit. But also notice, see where all the 4s are? They're along a diagonal. Do you see where all the 8s are? They're along a diagonal. So they're easy to find the number because they're all in the same sort of more or less location as you're looking at it. You can find them all quickly. All right, so what we're going to do is we're going to take a look at finding, in fact, the question asked, determine the number of ways to get the following sums. So how in the world could you roll a die and get a 4? What numbers could roll? A 3 and 1, a 2 and 2, or a 1 and 3, right? So they're all right here. Let me highlight them because they're right here, right? There's my sum of 4. So I can roll a 1 and a 3, a 2 and a 2, or a 3 and a 1. There are 3 ways of getting a 4 in this table. So the question simply asked you how many ways. You can simply write down how many ways. If you want to jot down some work to remind yourself, you can do that too, although it's not required. Okay? So these are the 3 ways that we just found to get a 4. How about an 11? How many ways are that you see 11s on there?
2,
There are 2. How did they happen?
5 and 6, 6 and
5 and 6 or 6 and 5? Now I'm not going to list the next one out because I'd have to list quite a few things. How many ways are there to get an odd? Somebody said it. 18, that's right. There are 18 different ones here that are odd. Right, so if we were wanting to do odds, we would count up all the 3s, the 5s, the 7s, the 9s, and the 11s. Agreed? And there are 18. Now notice for a moment with me, how many numbers are in the table? Do you know? Somebody said 36, because there are 6 along the top and 6 along the side. 6 times 6 is 36, right? There's 36 different numbers in the table. They're not all different from each other, but there are 36 numbers in my table. So if 18 of them are odd, then how many are even? The other 18, half and half. That's what's going on, okay? All right, how about between 6 and 15? Now let's talk about what the word between means. What does it mean to say between 6 and 15? What am I looking for? 7, 8, 9, 10, 11, 12, 13, 14. I know we'll deal with the 13, 14 here in just a second. But the issue I want you to recognize first is that it does not include the number 6, right? Between does not include the end points. It means between, okay? So don't include the 6. The other thing that you'll notice is that some of these can't happen, right? I can't get a 13 or a 14 in that table, right? So I don't need to like look for them. They're not there. So go back to the table, and I want you to add up all the different ways, or count up the number of ways you get a 7, 8, 9, 10, 11, or 12. Did you get them, Tyler? How many was it? 21. Did somebody else count a 21? Mason does too. All right, we'll go with it. 21 ways that you get a number between 6 and 15. What does multiples of 3 mean? Okay, you guys are giving me multiples of 3. So 3, 6, 9, 12. These are multiples of 3. You might remember multiplication tables from probably 3rd grade. So multiples of 3 means it's a number that's divisible by 3. 3, 6, 9, and 12 are all divisible by 3. So if you look back in that table and count up all the 3s, 6, 9s, and 12s, how many do you have? 12? 12 ways. Okay, now before you get started on your homework, I want to show you something because their language that the book is using is odd. Okay, so I'm going to show you back on this slide because it talks about the dice again. It actually talks about a product table. Now, when I hear the word product, I think multiplication, and that's not actually what they're meaning when they use the word product here. So let me show you what they mean by it. It doesn't have to use necessarily the numbers 1 through 6. In fact, the book will not. But let me show you with the numbers 1 through 6 what they mean so you can do it yourself too. So imagine that you're doing a product table the way that they're describing it, and you'll know when you get there in your book. It will be very obvious what you're looking at. But let me show you what they're wanting you to create. They're wanting you to create the numbers just written beside each other. So when we have this one, here's a 1 and a 1, they're wanting you to write that down as the number 1, 1. Okay? They're just wanting you to set them beside each other.
Like in parentheses, like a set?
Nope, just like the number 11.
Okay.
There it is. Show that for us. And then they're going to do the number 1 and 2, and we're going to write what number down right there? 12. And so you can either write 12 or 21, I don't care, but you just need to make sure you stick with the same order every time. So if you're using this number on the right-hand side to be the first number, along the first number always needs to be the numbers on the right-hand side. So that's how I'm going to list mine. So this would be 12, and then 13, 14, 15, and 16. And then if I did row 2, what would I get? 21, 22, 23, 24, 25, 26. You guys could finish that process now, right? So when they refer to a product table, this is what they're referring to in this particular problem. You've got it on your group work, and I think there may be a homework question that relates to this idea as well. Yes, Brian?
What's the name of the table?
I called it a summation table. Sums is where I put the word right here. Yeah. And I mean, they describe this thing on the right. They talk about it being all the combinations of the two numbers written beside each other or something like that. But then they also call it the word product. So I just don't want you to get confused with that word product because I don't think that was well placed. I think they should have called it something else. But they didn't. So I just need you to know what it means. Any questions? All right.